Thank you, Brian. That's sort of the, supposed to get up now and say I'm trying to figure out whether I'm 10 feet tall or 6 feet under. I am obviously pleased to be back in the Triple Cities. I came here to IBM, as Brian said, in 1950. It was my first job, our first home. Our children were all born in Endicott in Ideal Hospital. And, of course, we moved away in 1960, and I got back many times for several years, business-oriented as well as to see friends. But I haven't been back for a long time now, and it's been a great visit. We had a chance yesterday to meet with some of the people that did the 1401, the ones that are still around, and we had a ball, frankly. I had a ball. I hope they did. I think Susan told me that maybe take about 20-some minutes initially and then ask questions, and I was supposed to start at 1:30, so I guess I'm through. I did want to, by the way, I might also mention, I'm a native North Carolinian. My wife is a native Georgian, and we were accused of going to Yankee Land when we left North Carolina. And we said, well, we're going to go up and get 2 or 3 years experience and come back to the right part of the world. 33 years later, we got back. I want to talk briefly about some of the history of 1401-like stuff before the 1401. In the 1880 census, it took them 7 years to compile the results of the census. And they had decided to significantly expand what would be covered in the 1890 census. And the estimate was it was going to take 13 years to compile the results of the 1890 census. A gentleman named Hollers came along, and he devised a system where the census taker would have a punch card and a device so that depending on the answer from the people, he would get a hole punched in the card in the right place. That card would go back to the central place, the Hollers machine itself, and a device with spring-loaded pins come down where there was a hole. It would go through the hole and go into a pool of mercury for contact. EPA wouldn't like that too well. And then it would register on a dial one position each time it sensed a hole in the card, and the person would read the dial. They completed the compilation of the 1890 census in 3 years. Now, this was a one-function machine. They used it again in 1900, but it could do one application, Census Bureau, census taking, and compiling census, nothing else. The Hollers were smart enough to realize that that's pretty limited business opportunity, and he first incorporated a very small control panel so that the customer could now, with wires, much holes in the control panel, wire from the proper hub to the proper hub around, and have other applications run in the system. And so he got some more business, although he actually lost the 1910 census, I believe it was, to someone else. The next step was making that panel larger so he could do a more complex application. But now each time you wanted to change applications, you had to replug the control panel, tear it up, tear it down. So they said, well, how about removable control panel? We'll have a pre-wired panel, and for one application, when we're going to run the next one, we'll just remove that panel, take the other panel, plug it in, run a new application. The accounting machines unfolded the 285, the IBM 402, 405, 407. All of them were control panel controlled machines. 407 had a control panel like that. And when it was wired up, it looked like a bunch of spaghetti laying on there, and it was really difficult to wire. In the mid-50s, a company, Bull, over in France, announced electronic attachment to their accounting machine. And IBM Europe was pretty concerned because they were taking business. Can everyone hear okay? Yeah. And they came to the corporation and said, we got to do something about this. And so the big planning study resulted in something called the Worldwide Accounting Machine assigned to the European labs for development. When I came on board in '57, as Byron indicated, my first assignment was to assess the WAN, see if it was the right machine, the right cost, and so on. And they had been greatly concerned about cost, but as I looked at the WAN, I was not really concerned about the cost because it was a control panel machine again. And technology was on the move, and it was clear that we had to get away from those control panels. But if you take a punch card installation with panels, you had the accounting machine, reproducer, collator, interpreter, and so on. Each one had its own control panel, so it was a mess. And that's from the beginning of the 1401, when we decided, recommended we terminate the WAN program, and it was accepted. Unfortunately, we had a guy named Fran Underwood in the Endicott lab in those days. Very creative guy who had been in the field with IBM, customer engineering, what have you, made some recommendations out in the field, but he didn't get a lot of response from his local management, so he sent a recommendation directly to the lab of some of his creative work, and they said, hey, come up, we'd like to talk to you, and they hired him, fortunately, into the lab. And he devised an architecture that was extremely efficient. Back in those days, one thing that's very different these days back in that time, efficient utilization of resources, frankly, is something we sort of lost. We had to work very hard to make efficient utilization of resources because we couldn't afford it anymore. Ferrite memory was very expensive, and so we had to have a system that used a small amount, and it was a small amount. Matter of fact, our Enter machine had 1,400 positions of memory. And I told my grandson that, he's a PC buff like all of the guys. He said, Granddad, there is nothing you can do with 1,400 positions of memory. And today, they don't pay any attention to that, but that's what they got gigabytes or something. So, anyway, we had a great advantage in a lot of ways in those days because I had spent a year of my time in service, and then punch card installation as an operator and a programmer, then a manager for 12 months in Korea, serving 36,000 GIs with all their data processing needs. So I understood this punch card installation. Fran Underwood had been in the field, he understood well. So we had a known target to go after with the 1401, these punch card installations. We knew pretty much what they had in them, what applications they ran, and how much they were paying IBM. So we established a set of goals, functions, price targets, and actually I would say the company established a schedule for us because we were being threatened with competition. And I would just have to say this, the timing was wonderful. New technology was just coming in. The 7070 system was under development. It was maybe 2 or 3 months ahead of us. And they were solving some of the problems with the SMS world that we didn't have to solve because they were just ahead of us at that time. The people coming into the lab at that time, we were really fortunate. The other people had been in the punch card world, electromechanical world. We were now getting electronics people in the lab, which was crucial. This made it as a side issue. There were some people in IBM, I think, headed by Poughkeepsie people, that tried their best to get the corporation to move all electronics out of Endicott and make Endicott an electromechanical laboratory. And fortunately, Jim Troy, the lab director, was able to ward that off. And of course, we would never have had the 1401 if it hadn't been for that. New printer. A new printer was already in development in the lab for a tape-to-print operation for large systems. They were not focusing on the volume-area accounting machines. They wanted a tape-to-printer for large systems. But we quickly analyzed that printer and determined that that would be an ideal printer for a smaller system to replace all these punch card installations. And Joni Dager, that ran that program, and I had a lot of interesting interactions. And later on, even after the success, where Joni said, well, 1403 really made the 1401 system. And I said, no. The 1401 really made the 1403. But I have to tell you, the 1403 became the standard of the industry for probably 20 years. It was a fantastic product. The other thing I'll tell you is that we set some pretty tough goals, and our team met all of the goals. Met the schedule, met the function, met the cost. Well, I have to tell you, we almost met the cost. For the entire, some of the fellows here heard me yesterday, and so I apologize for the repetition, but we set a target cost for the entire system, the printer, the card reader punch, and the processing unit showing $25,000, because we know that would give us a $2,500 a month rental for the entire system, which was our target. We got the final estimate in before announcement, and it was $25,050. We missed our target by $50. And I had bet my boss in White Plains we would make the target, and he had bet me a felt hat we wouldn't. And so next time I was in White Plains, he made me go down to the store and buy him a felt hat for $50 miss. Anyway, let's just see. Oh, one other thing about 1401 before I move on. November of 09. The Computer History Museum out in Mountain View, California, had done some analysis earlier and concluded that the 1401 was an important system to the evolution of the computing industry. And they actually went around the world to try to find old 1401s. They found one in Germany and bought it, brought it back to Mountain View. They found one in Connecticut and brought it back to Mountain View, and with some volunteers there, several of them retired IBM custom engineering people, they restored those two systems, and they have two fully operational, with tape, 1401s running in the Computer History Lab in Mountain View. And in November of 09, they had a celebration of the 50th anniversary of the 1401. And some of us got invited out, and we had some of the 1401. I wish all the 1401 people could have been there, because it was a tremendous evening. I spoke to the people. I had asked them when they asked me to speak, I said, approximately how many people do you think will show up? And they said, well, maybe 160. We occasionally have 180 people, but we don't really know. 550 people showed up for that 1401 celebration. And when you talked to quite a few of them, I was quite pleased. Quite a few of them said, 1401 is the first system I was exposed to, you know. I got exposed to it in school and here and there, and so it was very nice. And I got to tell you one more thing. 9 years after we shipped the first machine, I knew it was shipped to Time Life in Chicago. 9 years later, I was in STD, running STD, and got a call from my marketing brethren. Their division headquarters was across the street. Said, I want you to come to meet with the customer. And, you know, in IBM, when they say customer, you respond. So I said, I can be there in about 30 minutes. I said, that's fine. I said, wait a minute, what's going on with the customer? I don't want to make a cold call type thing. I want to know what the problem is. No problem, nothing, you just come on over. Now, I don't necessarily trust all the marketing guys. I went over, and they came up and introduced me to two guys from Time Life in Chicago. And one of them stepped forward and said, I was the guy at Time Life responsible for installing your first 1401 system. That was a real pleasure to meet him, and we chatted for a bit. And I said, could I ask you a couple, 3 questions? He said, sure. I said, what was your initial reaction to the 1401? He said, well, the ease of installation. He said, we'd had new systems in the past. We had trouble with getting them going and what have you. Our application was up and running very quickly. I said, well, that sounds great. And I said, move into the future a little bit. What was your reaction to 1401? He said, people around us would not believe that we didn't ever have any problems with that system. It just sat there and run. And he says, as a matter of fact, it's still running 9 years later. And I said, well, I'm batting 1,000. I probably shouldn't ask you the third question, but I got to it. What didn't you like about the 1401? Now he paused for a little longer that time, and then he said, that you didn't give it to us 5 years sooner. You know, so we still made out pretty good. To me, Endicott, at those times when I was here, was the center of IBM's success. We were producing volume machines that were very profitable and generated a broad expansion of the customer base. The high-end machines got a lot of attention, the big new computers, a lot of press and everything. But we were really in Endicott, broadening the base of IBM customers dramatically and providing revenue and profit. Let me move on to the System 360. That's development started around 60-61, and as many of you know, I'm sure, IBM had several diverse architecture machines. Had 1401, had 1620, I believe, was out by this time. We had the 7070, we had the 705, 708, we had the 709, and 790s and what have you. And so the customers couldn't use these machines together very well. And you couldn't attach the common I.O. Once you attach it to one, you had to do a lot of work to attach it to a different one. It's a different architecture. So the 360, for a common compatible architecture, from small to large, for commercial and scientific installations, common input-output devices, and two major operating systems, was a profound move in the computer industry. And frankly, it was almost too profound. There was new technology across the board, not only in the semiconductor area, but in the input-output areas, the disk files, the printers, and everything else, tape drives. And it was, well, I don't remember exactly what it said, and either I think it was a Time article, but something like it was a new bets or company kind of move. It was really a bold, risky move that Tom Watson, the decision he made. And it was very difficult to get out the door. We missed a lot of schedules that had been committed to customers. And Tom Watson, early in my days in IBM, I found out that when you made a customer commitment in this company, you didn't miss it. And that direction came directly from the top, Tom Watson. And so it really hurt IBM and hurt Tom Watson and a lot of people in IBM because they obviously did not make those commitments without thinking that commitments could be. But we got through it with a lot of effort across the whole corporation. There could never have been, I don't think anybody else, frankly, could have pulled off that except IBM. One interesting aspect before announcement, in December of 63, it was going to be announced in April 64. Honeywell announced something called the H200 machine. The H200 was a medium-sized machine with new circuitry, new electronics, but it had one feature that was very important. It emulated 1401 programs. So they can walk into a 1401 installation and say, we'll take all your programs, just input them on our machine, and they run. And as a matter of fact, our engineers didn't believe it. I have a good friend in the Eastern region named Jim Gazelle. With one of his customers, he managed to go out to a Honeywell demonstration and see it, and he saw this thing really worked. So he went to Endicott because the system, this 360 Mod 30 was here, key to 1401 follow-on. And he read the riot act to him and said, we got to have emulation. Well, the 360 did not have emulation at that time. And I personally said that one of the best things ever happened with 360 was the H200 announcement. Because there was a hard-driving task effort to put emulation on the System 360 Mod 30 and 40, and later the 50. And with announcement, with the April 1964 announcement, emulation of 1401 was announced and included with that package. So without emulation, I'm not sure that the 360 would have been so successful, right? So that turned out to be a good thing. Programming was the most difficult part of getting the full 360 out the door. We struggled mightily, frankly, with the operating system 360. And I have to tell you a little story there about that. Fred Brooks had been a key architect of the System 360 and the key manager of the OS 360 operating system until about 1960, late 66, I believe. He left IBM and went back to the University of North Carolina and started a computer science program there. Well, a year and a half or two later, we were still just getting the final commitments out on OS 360, and I had a call one day from Tom Watson's office. Said, Mr. Watson is meeting with Fred Brooks to have lunch, and he'd like to have you join them. So I naturally said yes, and we had a nice little lunch, but when we got through, Mr. Watson turned to Fred and said, Fred, you promised me faithfully you would not leave until the OS 360 was in good shape. He said, look what happened. Tell me, what did happen? And I'm sitting there thinking, well, Fred's back, and Fred's going to say it was in great shape when I left. Those guys came along, screwed it up. But Fred didn't say that. Fred said, Tom, I had two groups pushing the OS 360. One of the architects, and the architect said, Fred, we cannot make the schedule. But for goodness sakes, finish the architecture, and it'll be good. We're going to be late, but it'll be good. And another group that said, if you get those architects out of the way, we can make the schedule. And he said, I was rather interested in making the schedule, and so I went with the second group. And then he said, Tom, that decision I made probably cost you about $100 million. Of course, he's back in the university now. But that's probably at least that much, because the effort that to straighten out OS 360 when the architecture wasn't complete was a mess. But it finally got done. And I'll just, on the 360, summarize by saying it was very strong in the middle of the line. It was weaker at the high end, and comparatively speaking, and weaker at the low end. Now, I'll mention the high end first. CDC and Cray and what have you had faster machines than IBM at the high end. And Tom didn't like that. He didn't understand why 35 guys in the janitor, as he called it, in Chippewa Falls can build a faster machine than IBM engineers. And it's pretty hard to answer that question, by the way. But it was a long struggle for IBM to get to the top speed machine to high end. The low end line was a little different. An outside organization, I'm not sure, Gardner Group or someone, they had done an analysis and they said the system rental range from $2,500 to $10,000 in April of '64 when IBM announced the 360. IBM had 87% of the business in that range, in that area. They said 5 years later, in 1969, IBM had 47% of that business. Now, the 360 was above that, most of it. Most of the 360 was a very successful product, but it somewhat left the lower end of business. And Susan, you'll have to tell me when I'm running too long. Frank Carey was chairman at the time, and Frank said, I want to separate off the low end internally and make it an integrated division, development, manufacturing, service, and marketing in one division. And I want to headquarter it out of the New York area, but they got to go with a very specific objective. So they had a task force make this study of how you would do that. They came back to Frank and said, That's the wrong thing to do. We got one face to the customer, one marketing face to the customer. You can't do that. He said, I want to do it. Don't tell me, come back and tell me how to do it. They came back the second time actually and said, really shouldn't do this. He said, you didn't hear me. We're going to do it. So let's tell me the best way to do it. So they set it up, General Systems Division. They were assigned from sort of the middle part of the line down. And great products came out of the General Systems Division. They started, I think, in about 71 or 2. I joined it in 74. And we produced System 32, 34, 36, 38, and the Series 1 and the Mini Computer World System 7. And then toward the end of it, it's GSD, the PC. And all were very successful products. And I just make one observation, or I always have to make this observation on the PC. We in GSD's technical side, development side, want to make a proposal to the company for building a PC. And our group executive, there was a proposal already in the works up in the Advanced Systems Development Division. Our group executive would not let us propose such a system. And the system that ASCD put together in proposal was a sort of a traditional IBM approach. We're going to use IBM technology. It's going to take us 18 months to get it out, and then it's going to cost us a fair amount of development, so we'll lose money for several years, but 4 or 5 years from now we'll begin to really make money. Well, Bill O was working with me as my head of my staff. I had a real small staff in Atlanta at that time. I had Boca Raton as one of my operations, Rochester, Minnesota, and Austin, Texas. Bill and I talked one day, and I think it was Bill said, look, why don't we put together a prototype system right here in headquarters? Our locations, we pushed them on IBM technology so hard, so we took a couple of small conference rooms and knocked out the wall between them, and brought in a couple of guys from Rochester, a couple of guys from Boca Raton, and the guy who was my administrative assistant at the time was an architect. 6 weeks later, we had a prototype PC running with Intel technology. 6 weeks. And when we brought our division president down to show him this prototype PC, things began to change. And of course, very quickly, that direction, we transferred it to the local lab. That direction became the source of the direction for the IBM PC. And Frank Carey again, there's a lot of things IBM had to do different to get the PC. In our division, we showed it to our marketing people. We don't want it. We can't afford to market that thing. So we had to go outside for marketing. Computerland, somebody may remember the early days of PC marketing with Computerland. Anyway, there was a lot of challenges. Frank Carey became sort of the systems manager of the PC from the chairman's office. And he made things happen that the rest of us could not have made happen. There's no question about that. So he gets a lot of credit for getting IBM and the PC thing, and I'll just make one other comment about GSD. They reorganized GSD back into the rest of the corporation just after the PC was announced. And the PC was initially very successful, but I personally wonder what would have happened to the continuing run of the PC if they had left it out in a dedicated focus group who had, that as one of their main objectives. We might still be in the PC business. As you know, we sold that business some time ago. I've covered most of what I wanted to tell you. I just want to say that we're fortunate, all of us in IBM, that Tom Watson Jr. wound up running the business. IBM for a long time was basically a family business. Tom Sr. He's I think he actually joined before the IBM name. He joined in 1914, I think. And in 1924, he renamed it International Relations. And he was IBM, fortunately. He was great. as we all know. Tom Junior came along, and we're all, a lot of times the next generation doesn't work out near as well. It begins to falter pretty bad. And we're all really fortunate that Tom Watson Jr. was a terrific leader, very smart, very competitive. He didn't like to lose anything. And so we're really fortunate in that sense. And I had a chance to have quite a few interactions with him, most of them good. A few times when I got taken to the cleaners, but I probably deserved it. But he was very, very impressive individual. He was the man that also in 1957 said, all of our future products will be solid state. No more vacuum tubes, solid state. And it caused a little difficulty in the 1403. There had the chain printer with the type going along the print line very fast. The hammer had to be very precise in timing of hitting the print properly. And driving that hammer took a spike of 7 amps. And with solid state technology at that state, it looked like we couldn't do it. And so the printer group said they went to Ralph Palmer with our support and said, we got to have an exception for the print Magnum drivers. And Ralph Palmer said, no dice. You've got to find a solution. And they did. It was Delco, by the way. But he's the one that set that direction as well. But I told the people yesterday, somehow Intel they had their antennas out, and even while we were still in Atlanta, just with our prototype system, they found out we were doing something with Intel. By the way, we considered whether we were going to use the Motorola or the Intel, and decided to use Intel on our prototype. So they called and asked to have a meeting with me in Atlanta, Intel technical people. So I met with them, and the first thing they did, went into the conference room, the chalkboard there, he had a long roll of paper about that high, and he began to unroll it across there. And you could quickly see this was a long-range plan. And I said, wait a minute, I'm not permitted to see any proprietary information. And he said, are you kidding? We show this to everybody. And it was their strategy for the next 5-6 years. They had laid out their plan, and they pursued that plan as their additional units came along. You realize that they knew what they were doing 5 years down the road, so they did a great job. We built the prototype in Atlanta about 6-8 months before that. It didn't take too long to get from that initial prototype because we were using outside industry technology that was, quote, available. So it was probably, I'm guessing, 6 to 9 months. One of the reasons it took the time is, like I said, it broke a lot of IBM traditions. Tell you another thing, just on a different subject. The Series 1, we tried to get in the mini computer business in GSD. DEC owned the mini computer world. And we went after the mini computer world, and this is a purchase-only business. And most of the time, they sell them in volume. 10, 20, 30, 40 units at a time. But we put together our Series 1, and we had technically as good a product as they did. And we put some price on it, and then we went to the financial people and the legal people to show them our discounting like DEC did. Volume, if you bought volume, we got a discount. Our legal people said, that's illegal. You cannot do that. They said, if you'll show me, you want to make a 30% discount for some volume or what have you, if you'll show me the 30% cost you save, then we'll talk about it. Well, we couldn't show them that much. And it took us a few months, and then the light bulb went on. We said, wait a minute, let's put together the cost analysis that we're going to sell 30 units at a time. And that's our base system. And now, how much premium does it cost you to only sell one? And it's easy to show that it costs you at least 30-40% premium. And so we were able to get that approach through, but only because we finally woke up to the right approach. customers that bought deck machines attached various things and modified them and what have you got inside the covers for the machine to attach things, their own devices and what have you. So we built the Series 1 system so the customer could get under the covers and do that as well. Walt Petticord, the director of personnel for the IBM company, non-concurred with Series 1. We do not let anybody under the covers of our machine. And he was concerned about the organization, the unionization and what have you. And so we took a complete Series 1 unit, got the IBM plane and flew it up to Armand, took it into CMC and showed CMC exactly what the Series 1 was and exactly what we had in mind and letting the customer get under the cover. Walt Petticord was there and said, I did not concur with that. We cannot do that in the IBM company. And Frank Carey said, how does DEC do that? Does DEC do the same thing you're doing with their customers? And we said, that's exactly what they do. Frank said, let's go do it. And Series 1 did pretty well to be going against the mogo of the industry. DEC was a very powerful, very strong company. Of course, DEC is now no longer DEC.